Good evening, ladies and gentlemen. I hope you are well. So my task today is just to go through some exam questions and help you to be able to understand what is it that you have to look at when you are answering these questions. They're still similar as the one for the assignment, although in the assignment you are doing on your own. Now it's an exam context. So you still apply the same thinking. There's nothing that has changed. It's just that you are writing an exam without that environment of an assignment. So I have looked on different topics. That is will be the one that I know that you'll be getting more marks will be the one of simple interest, discount, compound interest, effective interest rates, nominal interest rate, between two nominal interest rates. I'll just take you through on, I'll get some examples on each and every of the topics, and also some of the questions which are related to annuities, some of the questions about amortization, some of the questions about the bonds, and also if we are going to have time, we'll do data handling. But I think that one I've put it to be the last in case we don't have time, we don't reach there. Here's one of the questions. I've picked up all the exam-related questions. This question is about simple interest. Okay, so it's one of those questions that you know good you should be getting 3 marks. Here they say this lady or guy invests 1,500 in an account, earning that percentage. The balance in the account 16 months later. Okay, so now what is important for us is to know what is a simple interest formula. The simple interest formula will be we are looking for the balance, that is the accumulated amount. The simple interest formula, it's important to know which formula you can use, so then you know how to break down. So I'm going to be doing this process slowly, so then you can be able to practice on your own. So here you are given, this is a present value because this person is doing this thing now. So now the present value here is 1,500, and then the interest here, which is your R, is equal to 0,0657. And then here the balance in the account 16 months 16 months later will be equal to. So in this instance, this is in terms of the months. So now what you do, you're going to have your T is equal to 16 divided by 12. Okay, because now it is written as 16 months, so you want to have it as equivalent as in years. Okay, so that's you're dividing by 12. So now here is your formula. You are looking for an accumulated amount because that is an amount, a balance in the account in the future. You don't know this, so now this is a formula you are going to use. So now your S is going to be equal to 1,500 into 1 plus 0,0657. Be careful on how you convert your thing. This is not equal to 0,657. I'm just pointing out the common misconceptions that you can find or common mistakes. So this is 0,0657. If you are not sure, plug it into your calculator so that you can get the correct value of your interest. So this is going to be equal to 1631.40. So this one is straightforward. The only thing that you needed to take care of was this the time period. Okay, let us look on another example. This example, you are told that the bank is a discount rate. Already you know what they are talking about, the discount. So you are thinking of a discount formula. So there's many of the one that you can use. Let's just look what kind of information that you have here. So you know what is the simple discount formula. It is P is equal to S into 1 minus DT. And then I want to point out a common error that you need to be very careful about is not to write your formula as S is equal to P1 minus DT. Okay, so now be careful about this. This is an incorrect way. I'm pointing out the common errors. common mistakes that we would have. Okay, so now this is a formula that we are going to use depending on the information that is given. So the discount rate, you are told that the discount rate is equal to 0.12. You need to pay the bank 5,000 in 6 months' time. This is the amount that you need to pay in the future in 6 months' time. So now your amount in the future that you need to pay in 6 months' time is 5,000. Remember, we said your time, if your time is 6 months, so now 6 months, you need to divide that and write it as a fraction. So you're going to have 6 divided by 12. Okay, so now the amount of money that you will receive now, yeah, that means they are looking for P. So what is important in this question is for us to be able to convert time and put it and divide it by the units of the time that is given. So here the unit is months, so we are going to divide by the number of months in a year. So we are looking for P in this case. So you're going to have S is equal to, let us substitute, there is our formula. So our P is equal to, our S is 5,000. So our P is, our S is 5,000, 1 minus 0.12. And then our T, I need to multiply, T is equal to 6 over 12. Okay, so you plug this thing into your calculator, you would find that your answer is going to be 4,700. Okay, so what was important? This was the critical aspect about this question. Okay, I always suggest that to break down all the information, write it into a mathematical way, like have what is your D, what is your S, what is the formula, then you just plug in everything. At least you are aware what is it that they are looking for. Okay, let us look at this one. This Frieda borrows 7,500 from the bank at a bank interest rate of that much per year, compounded weekly. The amount Frieda will pay back after 78 weeks will equal to. Okay, we need to be careful about this question. Okay, this question is a compound interest question, no doubt about it, because now your interest is compounding weekly. We know that we are working with a compound interest. So we know what are the formulas for the compound interest. It will be S is equal to P into 1 plus I, okay, over the number of compounding periods to the power, the number of compounding periods and the number of years. Okay. Now let us break down the information that is given, because this question is very tricky. Okay, so now Freda borrows this amount. This will be your P, which is 7,500. Okay, and then the interest rate here, that means your I is equal to 0.26. This thing is compounding weekly. We know when something is compounding weekly, your compounding periods is equal to 52. Okay. So the amount that Freda will have to pay back, okay, will have to pay back, I want to write here, where N is equal to M multiplied by T. So this is the formula that you're going to be using. And then I just want to bring to your attention, Wuti, what is our N in this case? Okay, I just want to have some comments from the floor. What is the value of N in this case, in this question? The number of payments, that is your N. What do you think is the number of, or what is your N in this case? Remember, from your formula, you've got S is your future value, your P is your present value, your I is your interest, your M is the number of compounding periods. If your thing is compounding quarterly, that will be 4, and so on and so on. And then there's N, and then I'm saying N is equal to the number of compounding periods multiplied by T. So in this case, what is our N?
Okay, I'm thinking it is 78 multiplied by
Is 8 plus?
78 multiplied by
Is 78 multiplied by?
52.
52.
Yes.
Okay. Any other person?
Isn't it 52 multiplied by 78?
Okay, that's what Dimakato is saying. Sinenhlanhla, what do you think is our N here?
I was thinking the same thing, but when I put it on my calculator, I'm not sure.
Is not make sure.
Is not make sure, ma'am.
All right, let us look on the question, guys. Remember, what is our N? Our N, it is the number of compounding periods multiplied by T, and it should be the same units as our compounding period. A compounding unit. This thing is compounding in weekly, okay? And then here, in this case, we are not given UT. So we've got nothing to convert there. It's already been given to us. Our N has already been converted to us, and then it is 78 weeks. So if you're going to say your N is equal to 78 multiplied by 52, so you are saying 78 weeks multiplied by weeks. You are getting into a circular argument and then inflating your number of periods when your 78 is already in weeks. So there's nothing to convert there. Are we clear there? So be careful when you have the questions, unless here you were given that after maybe 2 years. We understand. We know TS, that is going to be your T, is an annual. Yeah? So now if ever this thing is annual, what you do, you take your T, you multiply by the number of compounding periods. You understand? So this one, we are lucky, it's already been done for us. So our N, that means our M multiplied by T is given to us as 78. There is nothing to convert there. Once you start doing this thing, you are inflating. You are inflating your number of periods. Okay? So look at what is it, what is the units of your time. Your units of your time is already in the units of our compounding period. So we are happy, we don't need to convert anything. Okay, so now in this case, you are going to be having your S. Remember, we said we are using this formula. Our S is going to be 7,500 into 1 plus our interest rate is 0.26, and then the number of compounding periods is 52 weeks. So you've got 52, and then we already have 78 weeks. So now we've got 78. So everything is in weeks. Our interest has been converted here into weeks by dividing 52. This one has already been given to us as in weeks. So we don't need to be converting anything. So our answer there is going to be 11,066,16. Okay, so that's the little bit of thinking that you need to bring in here. You must not assume every time when you get the questions like this, you must always convert your time. Okay, check if ever your time is in the same units as the compounding number of periods. All right, let us look on another one. Okay, here they are saying, this is an investment that is actually starting from somewhere, going from somewhere. Okay, so now this will be your P is equal to 20,000. Okay, and then your S is equal to 45,000, because you are starting from something, it has accumulated. This is an accumulated amount, 45,200, and then you are told, Guti, you can see, Guti, they are looking for a simple interest, because you are told Guti simple interest rate, and then your simple interest there, it is equal to 0.12. Then you have to calculate your time here. Okay, so now you know your simple interest formula. It is S is equal to P is equal to 1 plus RT. And then here, we don't know the time, the units of the time. So you know your S is 4,5,200, which is equal to 20,000 into 1 plus your R is 0.12 T. So 45,000 divided by 20,000. You're going to have 45,200 divided by 20,000. Okay. What is this? What is this? What is this? This is T. Okay. This is 1 plus 0.1 to t. So when you simplify, you just got, this one was a straightforward one. I want to go to the one which needs us to be looking at breaking down is 10,5. You can put it to the second decimal place, which is 10,0 years. Okay, let us look at the one which is going to whereby you have to apply ilento a timeline. Not that you don't have to apply it on the others, but sometimes once the situation gets complicated, it's best to get a timeline. So now we've got this situation whereby you've got this lady who's buying a painting for, so this becomes a present value of that thing. And then for 10 years, the value of the painting increased yearly by 20%, okay, increased yearly by 20%. Thereafter, the value increased yearly by 15%. The amount of money that Miriam can expect to receive if she sells the painting after owning it for 23 years. So it means now we've got a timeline here. You could see this thing is starting at T0, ne? And then your last term, that is your TN, because she's owning this thing for 23 years. So now you've got 23 years. Ne? So we are told in Toguti, this thing here, the first present value, because now you can see what this thing is increasing. Here at the beginning, this is 15,000. Okay, then this thing runs, the value of these things is increasing yearly for all those years for 10 years. So now you've got here you've got T10 here. Yeah? So now this one is for 10 years, that is T10. Your time here is 10, and then this when it comes here, it is going to have an accumulated amount. So this thing is 20 years. During this period, it is your I here is equal to 0,20. And then again, thereafter, that means from T10 to T23. So this is T23, okay? This is T23. Let me remove this. 23 minus 10, okay? 23 minus 10, how many years in between? It is equal to 13. So for this period, né? For this period, that is N is equal to, this is N. It is I2. I just want to show that this thing is changing. Your I2 here is equal to 0,15. And then here, this is your accumulated amount, your first accumulated amount at T10. And then again, during this period, your S1 is also the new present value for this new term. So we are looking for your final term, your accumulated amount. So we are looking the accumulated amount at the end. That's what they're looking for. The amount of money that Miriam can expect to receive if she sells the painting after owning it. So that is an accumulated, the value of your painting, of Miriam's painting at this period, at T23, which is going to be the second, because this thing, the interest rate changes twice. Okay. So the question is, what kind of an interest is this one? Obviously, it's an interest thing. Is it a simple interest? Or is it a compound interest? And why? Okay, look at this question. It's not specifying whether it's a simple interest or a compound interest. But by the way it's looking, this thing is increasing yearly. So that means every year during the 10 years, it is increasing. That is suggesting that it's compounding every year. It's compounding by 20% every year. So therefore, this is a compound interest formula. So now we are going to first calculate the accumulated amount for this period. So for this period S1, I am looking at this period. This is the first period I'm looking at. So my S1 here is equal to P1, okay, into 1 plus I1 to the power N1. And then our N1 here is equal to 10 because this thing is running for 10 years. Okay, so now our S1 and then is compounding annually. So now we don't need to worry about the compounding periods. So our S1 is going to be 15,000 into 1 plus our I there is 0.20, and then our N1 is equal to 10. So our answer there is going to be 92876.05. This is S1. Remember, we said our S1 is the same as P2, so this is the same as P2. Okay, so now we are going to be looking for the accumulated amount on this period. So our S2 is going to be equal to P2, okay, 1 plus I2 to the power N2. We've got everything in our timeline. So our P2 is going to be equal to, it is 92,876.05 into 1 plus the interest rate here is 0.15, and then our N is 13. This thing is compounding annually, so I don't need to worry about the compounding periods. This is just going to be 571,446.59. That is an accumulated amount on year 23. Okay, so now your answer would simply be this one. You don't go and add this and that one. This one has already been integrated, so you don't need to add it. Okay, otherwise you'll be getting into circular arguments. Okay, with this one, this deposit 900 into a savings account. This is a simple interest. This is compounding quarterly. After 3.5 years, she withdraws 1,000 from the account and deposits the account into another account, paying 11% interest per year, compounding semi-annually. How much is the total amount accrued from both accounts? There are two accounts here, 2 years after making the first deposit. So here, guys, I'm just going to show you the, did I do the timeline? It's important to do the timeline, but however, to read the story here, there is a first deposit. Remember, there are two accounts here. There is a first deposit, and then there is a second account. Okay, there is a first and the second account. So on the first account, she deposits this amount into a savings account, earning 6.5 interest compounded per quarterly. Ne? After 3 years, ne? And a half years, she withdraws 1,000 from the account. Okay, so now what we need to do here, before she withdraws, we need to first calculate the accumulated amounts on the time of withdrawals. Okay, so now what we are going to do is to say, let us look on this one and say, what is an accumulated amount on this first? So the accumulated amount, that will be your S1, is going to be equal to your present value, which is 900. Okay, this is a compound interest formula. 1 plus 0.065. This thing is compounding. Quarterly. Okay, so we know good when something is compounding quarterly, we are going to divide by 4, and then we are looking for this after 3.5 years. So 3.5 years is 3.5. We are multiplying by the number of compounding periods, which is 4. Okay, because our M is equal to 4. Then we get that our new our accumulated amount is 1,128.76. 7, okay, comma 84, okay. And then we said, remember this, what she does after this this period, she withdraws from this account E1000. So now your S star is going to be equal to 1127,84. She is withdrawing 1,000 soon after the end of the 3 years. So this is going to be equal to 127.85. Okay, that's what she has on this first account. And then what does she do? She goes and open another account, and then this account is, the interest rate on this account is 11%, and then the interest here is compounding semi-annually. That means it is compounding twice. And then we need now to, we know what this is the, when she withdraws 1,000, this is the amount that she's left with. Okay, so she withdraws 1,000 from an account, we don't know, and deposit it into another account, paying 11% interest per year, compounded semi-annually. So now she withdraws 1,000, okay? And then she deposits this amount into another account. Are we clear, guys? She's taking Ilento E1000, and then what she does, that is going to be your present value of this second account. Maybe it's Capitec, this other one, maybe it was Standard Bank. She's doing this, okay? And then we know Guti, we are told Guti, this thing is running for 2 years, this new account, because now she is going to run for 2 years. So now your T here is equal to 2, okay? So we are going to have this second account whereby we're going to be having the second account is going to be equal to 1,000 into 1 plus 0,11. Remember, this thing is compounding semi-annually. So we are going to have 2 multiplied by 2 is T multiplied by M. So this Capitec account is going to have 1238,83. Okay. So then we are saying this account as a Standard Bank, uthathe 1,000. The account needs to continue phela bakwethu. As much as a withdraw 1,000 wayifaka ngapha, the account isasenemali leya Standard Bank or a Time Bank, whatever bank, but there's still some money. That means this money still needs to continue, okay, being invested in this first account, same conditions, and then but the amount has been reduced. So now you need to calculate the amount which is going to be here. So the amount which is going to be here is going to at the end of the 2 years. So now the accumulated amount here is going to be equal to 127,85. This thing needs to run for, these are the similar conditions. It is 0,065 divided by 4, and then it is running now. And the thing is getting withdrawn. This account needs to run for 2 years because it's a new period. That's what they're saying, after 2 years. So now after 2 years, you're going to have 2 multiplied by 4. Remember, the first account is compounding. This thing is compounding quarterly. So anything that is happening here at Standard Bank needs to continue according to the original rules of Standard Bank. So now the accumulated amount in this first account, it is going to be this amount, which is going to be 145,44. And what is the question being asked? You are look how much is the total amount accrued from both accounts. So it means now your accumulated amounts is going to be this one on the first account and this amount on the second account. That is going to be what is being accumulated in the end. So now on the both accounts, that means both accounts On the both accounts, the amount is going to be 145,44 plus 1238,83. Okay, so now the total amount there is going to be 1384,27. Okay, this is just a contextualized story. It is important to break things down, guys. When you're doing problem solving, see the story and make it as informal as possible and say, okay, I've got two banks. What is happening in this bank? What is happening in that bank? Okay. I think it's all about practice and understand how these things flow. Okay. And then here, you are told what the simple interest rate is this one, and then equivalent discount is this one. You already know once there's a simple interest and a discount rate in the same question, you know you're going to get this formula. Just get this formula when you see those things under one. So you are going to have these two. Okay, these are the formulas that you're going to use. Why? You've got a simple interest and a simple discount in one. So you are given those two things. So now your interest rate is equal to 0,24, and then your simple discount there is equal to 0,205. The time under consideration, you are looking for T. You have your formula. You go to your formula sheet, and then your formula is saying, according to your formula, you are going to have R is equal to D over 1 minus dt, which is your R is 0,24, which is equal to your D is 0,205 divided by 1 minus 0,205. You are looking for your time. Okay, so you just play around and do your calculations, and then you find that your T is going to be equal to 0,711. And then you go and look at your answers and say, I don't have 0,711. And then you look on your answers are being put as number of days. So the suggestion is you need to convert this amount, multiply it by 365. Okay, if you multiply this thing by 365, you will notice that your answer is going to be equal to 260 days. Okay, here you multiply by 365. Why? Because your answers are suggesting into what this is in days. So this you need to multiply it by the number of days. If it was weeks, if it was saying 34 weeks, you are going to multiply this thing by 52. Okay, so that is another thing that is important in this question. This one, I think I need to do this one because there are people who are struggling with their logs. So I'm going to spend time on this question. So Richard needs amount for an overseas trip. Okay, how long will it take for him to save towards this amount if he deposits 25,000 now into a savings account earning 10.5% per year compounded weekly? Okay, let us break this thing down. This is an amount that he needs in the future. Okay, so that means your S is equal to 3835,42. Okay, and then how long will it take? They are looking for UT. Okay, for if he deposits, so your P here is equal to 25,000. Okay, into a savings account. That's the amount that he's depositing now. And then your interest there, your interest is 0.105 and is compounding weekly. That means your M is equal to 52. So this is a compound interest formula. So we know that our S is equal to P into 1 plus I over M, okay, to the power MT. So what is your P there? Your P is 25,000 into 1 plus what is your I? It is 0.105. And then this is compounding weekly, which is 52. Okay, and then this is to the power mt. Our m is 52t. All right, so your s here, your s is 30835,42. Okay, so you divide this amount with this, so you're going to get 1,233,416. I like to leave things to 5 decimal place and even more. Okay, especially if I'm going to be working with analogs to avoid truncation error. And then here I'm going to be having 1,002019. This is 52t. As you can notice, this is an exponential equation. So when we have an exponential equation, you've got y is equal to ax. So therefore, your x is equal to log of y over log of a. Okay, so that's what we are going to do here. We are going to start with our exponent as we have done here. This is a formula for the logs. So our 52 P is going to be equal to log of whatever is here, which is 1,233,468 divided by a log of this base, which is log of 1,002019. Okay, this becomes more simpler. So you are going to have your 52t is going to be 104,99. Then through simplification, you will see that your t is equal to 2,02. Okay, to the nearest is going to be 2 weeks. Okay. I'm going to highlight things that you are going to be bringing in from all nominal interest rate, number effective interest rate. Okay. Here is a question, okay? A question that you can expect when you are working with the amortization. Here you are given an information, okay? You are given the month, which is 196, and then you are told to go to on this month, okay? On this month, it's just an extract for this month, 196 month. You have a principal at the beginning, and then you've got an interest. You don't know the payment. You don't. You are given the principal repaid. You are given the principal at the end of the month. So the question that you need to answer here, you need to find the interest. Okay. So now, how do we calculate for an interest in this case? Okay, so we know, okay, we know Ubuti, our interest is equal to PRP. Okay, that's the formula for our interest. So we are looking for the interest rate, guys. We are only given an interest, but we don't know the interest rate. So now we know what is an interest according to our formula. This is going to be 8690,04. Okay, this our principal is this one, which is 948,004. Okay, and then what is our R? That's what we are looking for. What is our time? This is monthly. This is 196th month, but we are only given a period of 1 month. So we are going to calculate the interest rate during that month. So we are only going to be looking for 1 month, not 196. 1 month, only for 1 month. So it's going to be 1 over, this thing is compounding monthly, so it's 1 divided by 12. So we are going backwards, okay? So our R is going to be equal to 0,11, okay? So that will be your interest rate, the interest rate that you are looking for. What is happening here? That is an interest rate that you are calculating for this month. And then the question is further saying, what is the size of his monthly payment? Let's look at the information that is given. You've got all of these information, and then you know that for you to calculate the payment, you know that the principal, there's a formula which is saying a principal that is repaid. Okay, the principal that is repaid, it is a payment that is according to the formula. You can look on your notes. It is the payment minus an interest. Okay, that is an actual interest, not the interest rate. Okay, so we know what is a repaid interest from the formula, from the given information. We are told what is a repaid. So now we are going to have 17,114.67. What is the payment? The payment amount, that's what you are looking for. Okay, your interest is what has been given to you. Here's an interest. And interest is 86.90. That's what is given, the actual amount, not the interest rate. So this is going to be 86.90,04. So you can just get your payment. So your payment is going to be 25,804.71. Okay, so that, I mean, the one of amortization should be those questions that you are really happy to just get your free marks. Okay. Now here's a question for for the annuity. Okay. Remember, we've got different annuities. You've got an ordinary annuity. You also have a deferred annuity. You also have a annuity due. So each and every one of these have got different formulas. Okay, we are lucky that we can use our calculators. Okay, and remember, what are the things that you need to keep in mind? You must make sure that your interest rate, okay, your interest rate is compounding same time as your payments period. Okay, so okay, so let's look at this information before we can decide, is this an ordinary annuity or is it what is the present value of payments? The minute you see AMA payments, you know what, oh, it is that, it is an annuity question. So now we are looking for the present value. So it's a present value thing. The present value of the payments, we know what these payments, it is 250. Don't worry about this. Let's not worry about the amounts or whatever. It's 250. That is the payments. And then you are told, go to the payments. Ne? The payments are compounding, are being paid each and every end of the quarter, which is your 4. That is your compounding times of your payments. It is 4 because of the quarter. Ne? And then this is, you are told the time. The time is equal to, okay, the time is 12,5. Okay, and you are told in Toguti your interest, ne? Your interest here is equal to 0,75. Okay, however, it is compounding twice, so this is not the same as this. Okay, we're talking about the compounding periods. And then according to the rules, this needs to be the same as this. The number of compounding payments, the unit of payment, need to be the same as the one for the interest rate. So we've got a problem. Okay. So once we've got a problem as such, we need to go out of this context. Ne? Take our interest. Okay. Take our interest out of this. Go and get so for this one, our n is equal to 4 multiplied by 12,5, which is equal to is it equal to 50? So this is going to be equal to 50. Our n is equal to 50, but we've got a problem here. Okay. So we need to try and solve this problem. So how we solve this problem, we said, okay, fine. We are going to isolate this part and put it on the side and convert this interest into quarterly compounding periods. Okay, so we are going to get the formula, which is saying our J n is equal to, we've got Jn. This is a formula for converting between nominal interest rates. So this is going to be 1 plus J m divided by m to the power m. What am I doing here? What am I doing here? To the power m divided by n minus 1. Okay, this is a formula that you use to convert. What is it that we need to convert to? We want to convert, this thing is running semi-annually. Yeah? Semi-annually, we know what is twice. So now we want to have our n, we want our n to be 4. That is what we want. This is what we want. Okay, so now we are looking for the new effective interest rate. We are converting this one. I have highlighted it in purple. So our n is equal to 4, and then this is going to be equal to 1 plus. Which one do you want to convert? You want to convert this one, which is 0, yabona mistake? I'm also doing it. This is 0.75. This thing is compounding semi-annually, which is 2, and then you are going to have on your numerator, it is 2, your m is 2, and then your n, what you want to convert, is equal to 4 minus 1, and then you plug into your calculator, and then your interest rate that is compounding quarterly, it is going to be equal to 0.7. It is going to be 0.073098. That is a new interest rate that is compounding quarterly. So now that you've got this one, you are no longer going to be working with this. So now your interest rate that you're going to be working with here is going to be equal to 0.073098, and it is compounding. It is compounding quarterly. So you just take this and put it into your calculator or your formula. So your formula is equal to 250, okay, into, that is a present value. Be careful, you need to choose the correct present value formula, which is going to be 1 plus 0, 0, where is 4 here? There's supposed to be 430. There should be a 4 here. Okay, 430. Okay, so this is 0.074098. Okay, divided by, it is still your m is equal to 4, and then here you are going to have your n. Here is your n. Your n is 50. Okay, minus 1. Okay, this is the present value formula, and then you divide this by 0.0743098 divided by 4. Okay, divided by into 1 plus 0.0. I must not do this thing early now. So 0,743098 divided by 4 to the power 50. This is to the power 50. So you've got to the power 50.
I wanted to ask, is it possible for us to use the financial calculator?
You have to use a financial calculator.
Oh, okay. Okay.
You cannot be doing, you'll be crazy by the end of the exam.
That's true.
I'm just doing this so then I can demonstrate. I can demonstrate to you, Uguti, how does this. Let me show you the formula for the Uguti. You've got different financial calculators, so it will depend which one that you are, the one that you are using. Okay. I don't know which one you are using, but I'm sure there are steps on how you can calculate these things depending on the nature of your calculator. So let me see. I want to get something here. It's an ordinary. Am I having the correct one here? PV ordinary. So for your calculator, you can just write in the short form, which is equal to your RA NI. Okay, just a short, the short form. Your R here is 250, and then your A, your N is 50, your I, which is this I, ne? Your I is 0,074398. You have to divide this thing, ne? Don't forget to divide it by 4. So it does not matter, even if you are going to use a calculator, you are not going to be saved from not converting your thing. You still have to convert, unless you've got a calculator that is powerful. Okay, if you've got a calculator that is powerful, that can calculate for you between two different nominal interest rates, then it's fine. But some of the calculators, they just work with only one compounding period. So it will depend how powerful your calculator is. So if your calculator can only take, if ever you've got same compounding periods for your payments and your interest, then you have to first convert. Otherwise, if your calculator can handle everything, then you don't have to. So go and check your calculator how powerful it is. Otherwise, if it's not powerful, you have to first convert. So you can't get to this stage without going through what we have gone through manually. So I've gone through manually because I wanted to demonstrate to you how did we come up with this. Okay, this will be the amount that you're going to get. Okay.
Okay.
So there is another one that you might get. Is the one of deferred annuity. Okay, a deferred annuity is when now you get an investment, you get an amount, maybe a loan, and then the loan, they tell you you will only start paying it at some specific period. They like to do it even when you're buying the house, when the salesperson, they want you to buy a house or a car, and then they will tell you, hi, you've got a payment holiday, you don't need to pay for 3 months. In December, you can enjoy your car or enjoy your house, and then you start paying in April. And then when you think, wow, I've got this bank is a very kind bank. There's nothing kind there. They are not kind. They just want you want your money. You'll still have to pay that amount. So now that is a deferred annuity. So now let us look on the aspects of the deferred annuity. The reason why I wanted to bring in deferred annuities is because it's one of those questions which, as an examiner, I would put in because there's a lot of problem solving that you need to put in. So you are assessing so many things there. So there are many cognitive levels of demand that you assess in one question. So the deferred annuity, make sure that it is once you practice, it is not that difficult at all. Let us look on how you do the deferred annuities, because when we are doing the bonds, we are going to bring in the ideas of the deferred annuity. All right. So now with the deferred annuity, let us read the story. We've got this guy who is 33 years old now, and then he's receiving an inheritance from his parents' estate. Hey, some people are so lucky. And then he wants to invest an amount of money today such that he received 5,000 every month for 15 years when he retires at the age of 65. Okay, if he can earn 9% compounded annually until 65, and then 5% compounded annually when the fund is paying out, how much money must he invest today? Okay, so now let us write the story. I'm sure if you look at this story, it is similar to the one that I did previously of the painting. Is it a painting? I think it was of a painting whereby the interest rate would change at some point. I think the only way to do this is to get the timeline. Okay, so let us get the timeline. Okay, the timeline here, we are looking for the present value now. That's what they are looking for. What is the present value now? How much must he invest today? Okay, so now he is investing this amount in that account. It's not an annuity, it's just a normal account. He invests this money until he is age 65. Okay, this is age 65. Okay, he's investing this amount. So this amount would have accumulated a specific thing, a specific value here. And then when he invests this amount, he is 33 years. So now he is age 33 when he's starting to do this thing. This is age 33. Okay, and now he wants to invest this every month. Can you see? Is each and every at the end of every 3 months when he no, this is what is going to be happening. This is going to be what is happening after he retires. We are going to wait about this information, but we are looking at this because we want to fill in here. So if he can earn 9% compounded annually, so here he can earn 9%. Okay, this is compounding annually. That is your M is equal to 1 until age 65. That means from age 33 to age 65, how many years? That is the time. The time here between 33 and that is the deferral amount. It is going to be equal to 32. Am I right? Yeah, 32. 65 minus 33, that will be this amount of that is a period that he's deferring. Okay, then afterwards, after this period, now he starts to get about 5,000 much. Yeah, khihliza investment yakhe annually. That is an annuity, so he starts to have annuity here. He starts to have annuity. It's an annuity. This thing is going to be paid until he is how old? How old? After he retires at the age of which age here? Every month for 15 years. Ne? So now annuity, if ever he puts this thing into an annuity, he's going to put this thing into an annuity for 15 years. So your N2 here is 15. Okay, so now it means your TN is going to be 15 plus 65, which is 80, but you are told go to this thing, he wants an annuity for 15 years. So this is your 15, and then you are told Guti, this thing when it's paying out is going to be 5%. So now your I2 here is going to be equal to 0.05, and then this thing is compounding. This thing is compounding annually. So now we are not worried. It is compounding annually. So we need to worry before we can get we can get our present value. We can calculate here. Here, the future value is going to be the present value of the ordinary annuity. Why am I saying it's an ordinary annuity? It's because you are told, Guti, this annuity is earning 5,000 at the end of every month. Okay, so now you can see here, Uguti, the payments are every month. Okay, however, the interest is compounding annually. There is the thing. Okay, so now this thing is compounding annually, but the payments are monthly. So there's a problem. Okay, so the payments are not equal to the compounding interest. I'm going to say interest. So now remember, when you've got a situation like this, what do? You need to isolate this, go and calculate a nominal interest rate, which is compounding monthly, because your payments are monthly. So whatever is being paid monthly needs to be compounding monthly. But the interest rate here, it is compounding annually. So you need to convert this annually. Remember, what is the formula that we are going to be using? We are going to be using this formula. So we isolate this and say our formula is going to be equal to J. We want to convert this thing to be a monthly. Okay, I'm putting this formula. You know the formula, we've used the formula previously. I'm just plugging in the values. So this is going to be 1 plus, we want to convert this interest rate, which is 0.05, and then this is the interest which is compounding annually. Okay, so we want to convert it to be monthly. So this is 1. This is going to be equal to 1/12. I'm just plugging it into a formula, guys, the one that we used. I don't want to be repeating because I'm looking at the time. So this is -1. So when you take this, you are going to get that this interest rate is going to be 0.0489. Okay, this is an interest that is compounding monthly. The focus here is on this annuity period. Okay, this is a period that I'm working with. Let me get a different pen. This is a period that I'm working in. I am referring to this. Okay, so now we need to calculate for the P ordinary. So now our P ordinary is going to be equal to, P is going to be equal to, what are the monthly payments? It is 5,000. Okay. What is our N? Our N is equal to 15. Okay, we've got our N, which is equal to 15. But remember, this thing is compounding monthly. So now your M is equal to 12. Okay, what does this imply? This implies that your N is equal to M multiplied by T. So now your M is 12 multiplied by 15. Then your N is going to be equal to 108. It's important to have these things in order before going to your calculator. So now you are going to have your N, which is 180. What is the interest rate that you're working with? You are working with this interest rate. Okay, this is an interest rate that you are working with, which is 0.0489. Remember, you still have to divide it. It's compounding monthly. Okay, you plug in this thing into your calculator. Okay, this is going to give you 636 925.79. Remember, this is a P ordinary. Okay, the P ordinary is the same as the future value of this deferral period. Okay, your FV is equal to your P ordinary. So whatever value at the age of 65, the value at the age of 65 is going to be this one. So now you need to discount this thing back. So this becomes the future value. So now for this deferral period, it is just a normal compound interest formula. So you're going to say my future value is going to be equal to PV into 1 plus I, okay, I to the power N. Okay, what is your future value? The future value is the same as this one for the ordinary. So this is going to be your future value, which is 636,925,78. Okay, and then this is going to be equal to your present value. That's what you're looking for. You're looking for the present value. The present value, 1 plus what is your I for this period, this deferral period. We are looking at this deferral period. This is going to be 0,09. This thing is compounding annually. So your M is 1, and then what is your N is 32 multiplied by 1. So you are going to have 32 multiplied by 1. So your PV there, your present value is going to be 40405,54. I'm going to dedicate the rest of this section to the bonds, because you will get a question on bonds whether you like it or not. There's no way that you're not going to get the question. And the equation Yama bonds, it is carrying so many marks, guys. It is carrying so many marks. You have to make sure which at least, because now you are asked a clean price, you are asked for an accrued a value, and so on and so on. So if there are no questions, I'm going to take you through the question that is about AMA bonds. I'm going to take you through the question about the bonds. So then at least I'll do this one, and let me see this one. Still the same thing. I'll do at least 2 questions and show you 2 different scenarios. So you are told that the coupon rate, we know the coupon rate is half yearly. So once you've got that, you know, when you've got a coupon rate, you're going to have your D there. I want to save space. Okay, so this implies that your D is equal to 14,7. Remember, you write you write your coupon as D, which is as not as a decimal number. Okay, you write it as 14,7, and then you have 14,7, and then you divide by 2. Okay, and then this is your maturity date. Okay, you look at your maturity date. You've got yield to maturity. Your yield to maturity, what does it mean? Your yield to maturity is for your Z, which is equal to, your yield to maturity is going to be Y divided by 2, which is, what is your Y? It is 0,135. This is the only one that you are going to convert to become a decimal. All right? So you're going to divide by 2. Okay? Once you've got that, you go and get your timeline. Okay, so you've got all in price. You are looking for 1, 2, 3 things. Okay, let us go and get our timeline. Okay, so here is our timeline. Here is our timeline. Okay, in our timeline, I think these ones you write, it's almost the same, similar way. It's only when the times are not the same. So now you are starting here, you've got an issue date when the bond is being issued. So this is an issue date, okay? You've got an issue date, and then you've got here, and then you've got here. I'm opening a space. This becomes your settlement date, okay? This is going to be a settlement date. This is going to be a coupon date. Coupon date before settlement. Yeah. Before, I'm just going to say before. Okay. This is the settlement. This is when you are doing settlement. This is a coupon. The coupon date after the settlement. I'm putting a star here. This is after. Yeah. Then there are coupons that are being paid here. that they are being paid there, that are being paid, and then you've got your maturity, okay? Your maturity date, you are told this is your maturity date. Your maturity date, you are told is a redemption date. It is 1st of January, 2028. Because this thing is paid semi-annually, you know, there was a coupon that was paid 6 months before this one. 6 months before this one, that is 1st of July. 1st of July, there was a coupon payment of 2027. Okay, and then you, even after this one, you know, Guti, on the settlement date here is 18th of April. You are told settlement date is 18th. It's 18th of April. And then let's look at the year. The year is 2013. Okay, so when you are here, you know, Guti, this is guiding you. This thing is guiding you. Okay, this 13th of April, how many days? Oh, okay, you've got 2 periods here. Okay, you've got 2 periods here. There's a period of coupon. There's a first period here, okay, until the end. You've got these periods here. You've got the first. This is a full period of your annuity, and then from here to there is your odd period. So now you've got 2. So now you're going to be doing your calculation on these 2 periods. Okay. So you know, good thing from the 18th of April 2013, the next coupon date that is closer going forward, because now this is guiding you. This is closer to July, so it's going to be 1st of July of that year, 1st of July of 2013. Okay, and then here, if you are on the 18th of April, the previous coupon date, it must have been paid go January. So now you are going to be having 1st of January, 1st of January of that year. Okay, so now we know, Guti, this period, let me get a different pen. This period and the, I want a different pen. This period and this, we are going to call it R, okay? This is our R. And then this period between the coupon date and the coupon date before the settlement date and this one, this is going to be equal to our age. These are very important dates, okay, for our calculation. So we know what the next coupon date here, if this is 1st of July, is going to be 1st of January, 1st of January 2014. And so on and so on. There'll be coupon dates going forward. But you are just analyzing your timeline. So then you've got the story working. Okay. Once you've got your timeline for each and every calculation of your bond, make sure that you've got your timeline in this form. Once you do this, you are able now to do a problem solving now and say, I've got my timeline. Now, once I've got my timeline, I can start calculating. The first thing I'm going to be calculating is going to be my R. Okay. I need to first calculate my R. Okay. So here, I need to calculate, those are the important points. I need to calculate the number of days between this and that. So that is my R. Okay, let me first calculate my R. Okay, how do I calculate my R? I know that my R, it is between 1st of July. Okay, 1st of July minus what is another date is 18th of April. Okay, and look at this. I'm not worried about the years because this is within the same year. So I'm looking for the number of days between the 18th of April and 1st of July. Okay, the years are the same, so they just cancelled out. So I'm not worried about the years. I only look for the number of days between 18th of April and 1st of July. How do I calculate that? I can go to my number of days here, and then I'm looking for 1st of July. 1st of July is 182. Okay, so now I've got my 182 there. Okay, there is my 182. I've got my 182, and then I need 18th of April. I go to my table. I'm looking for 18th of April. I've got 18th of April, which is 108. Okay, so there is my 108. Okay, so I've got 108. So this implies that I've got 182 minus 108. So my R is equal to, this value is equal to 74. Okay, so now I've got my I've got my R there, which is 74. Okay, so I need to also calculate for my H. Same thing, my H is equal to, okay, my H is 1st of July. We've already seen what is 1st of July is 182. Okay, it's 182 minus, and then our H, there is our H. Our H is 1st of January. So now it's minus 1st of January. You've got 1st of January. How do you get 1st of, or number of days? 1st of January. This is on your appendix. 1st of January there is equal to 1. Okay, so now you've got 1 there, this one. First day, and then January is 1. So now you've got 1. So this is going to be 182 minus 1. So now we've got 182 minus minus 1, which is going to be equal to 181. Okay, so now you've got that, and then you are going to now to get your N. Those are the values that you need. Okay, what you need to also point here is when your R is greater than 0, your R is greater than 0, this is suggesting that you are working with a cum interest. Okay, when you're working with a cum interest, there's something that you need to focus on, especially when you are calculating an accrued interest. Okay, if it's a cum interest, there is a special formula that you need to take into consideration. So our R is greater than 0, so it's a kind of a cum interest. So now what you're going to do, we need to calculate our N. So our N here is going to be, how do you calculate your N? You look at your N in this form. Our N, it is these days. 1st of January is the period for this first period, the annuity period. Your N, it is this period. I should have written this. This is your N. When this is your R and your H, this is your N. Okay, your N is 1st of January. Okay, to 1st of July 2013. Okay, now there is a problem. If you want to calculate for your N, you should be having 1st of January here and 1st of January, and then you just minus the years. So once you've got a situation like this period is going to be giving you problems. So what you do, you ignore this period. Yeah? You ignore this period and look at the following period, that is 1st of January and 1st of January. After you get your answer, you add this one period. Okay, how do you do that? This is how we are going to do it. You've noticed, but if this one was 1st of January, there was no need for us to skip. You will take this and minus that. But in this case, this the beginning period, that means the coupon date after the settlement date, that is the beginning of your annuity here of this first period. So this one becomes an issue if ever it's 1st of July. Hence, we are going to ignore 1st of July and focus here and there. After getting the difference between these days, we're going to add one coupon, the one that we ignored. Okay, so our N here is going to be equal to, our N is going to be equal to 1st of January 2028 minus 1st of January 2014. So this is going to give us 14. Okay, so this is annually. This needs to be multiplied by, because we are working semi-annually, by the number of compounding periods. So we are going to have 14 multiplied by 2 because this is half yearly. So now this is the number of compounding periods, which is going to be equal to 28. Okay, remember we said there is one coupon years that we have ignored. We need to add it. So now we are going to have 28 plus 1, which is equal to 29. Not every time you are going to ignore, guys. Let me emphasize that. It's a strategy that to apply, especially if this date and that date, the months are not the same. Okay, well, the months when they are not the same, you have to skip and ignore this period. And then this is only one period. You will add it after you have calculated this period, after you've calculated this period. Okay, it's not always that you are going to be doing that kind of of calculation. So now you are going to be having your 29. Okay, that is going to be your N. Once you've got that, Manje, your life is easy. You are done. Now you need to calculate for your, what is it that we are calculating here? We need to calculate for our P. Okay, so now to calculate for our P, we know the formula for our P. So our P, what is our P? We are calculating for our P here. This is the P that we're calculating for. We are looking for this P, which we are going to discount back to this period. So our P here, this is how you would calculate. You know the formula. Our P is equal to D A, this is going to be N Z, okay, plus 100 into 1 plus Z to the power minus N. You already have all of these components, guys. You already have these components. Remember, we said our D is 14,7 over 2. So now we've got here 14,7. We don't write our C, our coupon, as a decimal point and have 0,147. We write it as it is. This is divided by 2. This is going to be A. And then what is our N? We already have our N. We've calculated our N, which is 29. And then what is our Z? We've got our Z there. Our Z is 0,135 divided by 2. So now you've got 0,135 divided by 2. This can all go to your calculator, which is 100 into 1 plus what is our Z? We've got our Z, which is 0,135, okay, divided by 2. And then what is our N? Our N is 29. Okay, this can all go to your calculator. You don't have time of doing this thing manually. Okay, so your answer there is going to be equal to 107,55174. Okay, I'm leaving these things to the 5 decimal place, so then we do not have my errors. Okay, so now you've got your present value of your bond. You are not done. You were asked to calculate. Let's see what you were asked to calculate. You were asked to calculate for your all-in price. Okay, so we only have the first part, the present value. So now to calculate for your all-in price, before we calculate for the all-in price, you need to check now this information and say, Once you've got your present value, if you are working with your cum interest, this is very important, guys. There's so much thinking that you need to remember here. If your case is your cum interest is when your R is greater than or 0. So if you've got that situation, it means you need to add, okay? You need to add a coupon into your present value if you've got this situation. But if your R is less than 0, okay? If your R is less than 0, you don't need to be worrying yourself. Okay, so when your R is greater than 0, this is greater than 0, therefore you need to be adding a cum here, and a coupon. So now your P that you are going to be working with going forward to calculate for your clean price and all-in-one price, your P now, I'm going to put it as this. Your P is going to be 107,55174. We need to add a coupon of 14,7 over 2, guys. It's over 2. So now your present value that you are going to be working with, it is 114,901.74, and not this one. Okay, not this one. Okay, why not this one? Is because your R is greater than 0. That's why you have to. Is it greater than 10? Greater than 10, man. Is it greater than 10 or what? That R should be greater than 10, not greater than 0. Should be greater than 10, I think so. Can you check for me on your notes? Your R should be greater than 10. Should be greater than 10 for it to become a cum interest. I think so. Right. So once you've got that situation, you know we are going to add. You don't take this as your present value. So now you go and calculate now your all-in price. Okay. What is the formula for your all-in price? Okay. So now we are saying our all-in price is the formula P is 1 plus 1 plus Y. Is it Y? What is all-in price formula here? Oh, 1 plus the yield, okay, to the power minus R over H. So that's the formula for all-in price, okay? So your P is the P that you've added because it's a cum interest. So you're going to have 114,873188 into 1 plus our Z. It is going to be 0,135 divided by 2 minus, remember what was our R? Our R was 74 and our H was equal to 181. That's what we calculated initially. So you are going to get your answer to be 111,87388. Okay, now the accrued interest, okay, the accrued interest, remember you are going to be choosing a formula for the cum interest. There are 2 interests there. So for the formula for the cum interest, for the accrued interest, it is written as H minus R over 365, okay, multiplied by C. I'm going to highlight what is a common error there. Your C, you are going to write it is C. Okay, it's not the payment of the coupon. So you're not going to divide it by a semi-annual compounding period. Be careful on this C. Okay, so now your H, you know what is your H? Your H is 181. You've got 181 minus 74 divided by 365. You multiply by C, which is 14,7, and not dividing by 2, because this is C, is not D. Ne? Then your answer there is going to be equal to 430,932. Okay, it's always safe to leave your things in 5 decimal place. Okay, and then you are going to calculate now the clean price. Okay, so now we said now the clean price. The clean price, we know the formula for the clean price. The formula for the clean price is all in price, okay, minus the accrued interest. Minus the accrued interest. So your answer there is going to be, you take your all-in price. Our all-in price, it is this amount. So you're going to have 111,87388. What is your accrued interest? It is this, which is 4,30932. Your answer there is going to be 107,56456. Once you get your R's and your H and your N, your life is much, much easier. So that's where the problems are lying with questions like this, okay? So here, what we need to do here is to break down what is it that we are given. We are given that our coupon rate here is equal to, that is our D here, coupon rate is equal to C, which is 14,7, okay, over 2, that is our D, according to this information. Yield to maturity, so the yield to maturity, we know we've got Z is equal to, the yield to maturity is 0,135. We are dividing by 2, according to this information. And what else do we need there? Okay, we know Uguti, we are given this according to the formula. Let us rewrite the formula. The formula for the present value here, the formula for the present value, it is equal to D A, this is N, that plus, this is 100, this is 100 into 1 plus Z to the power minus N. Okay, so we know that, so we are looking for UN. Okay, this is the N that we are looking for. So we can, for us to calculate N, we can only pick up this, okay, and say this is equal to that. So we know what is this part, this is equal to that. So now we know what is 15,04289, okay, is equal to 100. So we are comparing what we are given with the formula itself. 1 plus, what is the Z? Okay, let me write it fully. This is minus N, okay? So now you've got 100 into 1 plus, what is our Z? Our Z is 0,135 over 2, okay? This is what we are looking for. Then you've got 15,04289, okay? That's the only thing that you need here, okay? So I am not going to calculate this thing, guys, because there's another example. We've got only 2 minutes, but there's another example that I want us to look into, which can be helpful when you're doing these calculations. So here, this is an exponential form. You can just manipulate using logs. Then you can get the value of your N. You find that your N is going to be equal to 29. So there's nothing much that you needed to do here other than understanding good. Oh, according to this formula, I've got my original formula. This is equal to that. Okay, so there's nothing that you needed to be cracking your mind, doing Aboma timelines and everything. You just needed to understand what this is equal to that and do some calculation. Here's an interesting question. Yeah. So here in this question, in this question, I want some light. I want some light. This is too dark. This is too dark. Okay. Here is the information. You are given the present value. Okay. In this present value, there's too much information that you are given. You are given your D. There is your D. You are also given your yield to maturity rate, date. That's that's your yield there. You can even see it here. You can even see your N. There is your N. Your N is equal to 6. So you can just analyze the information that is given. You know this. This means this is for your R. This is R divided by H. Okay, so our R is 33, and then we know when our R is greater than 10, we've got a cum interest, a cum interest a formula. So we are even given what is an accrued interest. So we are asked to calculate the clean price. Okay, first thing that you do in this question, you've got everything that you need. You don't need to go and do your timeline. Then the first thing that you do is, what is my clean price? My clean price formula is equal to all-in price. Is all-in price minus my accrued interest. Okay. Then what do you need for you to get your your clean price? You need your all-in price. The accrued interest has been given. Okay. So now for you to calculate for your all-in price, okay, your all-in price, what you need to do is just to go and calculate this, plug this thing into your calculator, because everything is given to you. So then you can get your present value. So your present value, if you plug this whole thing into your calculator, your present value, you find that your present value is equal to 827,893.6. Okay, that is the present value. However, before you can even decide on this present value, this is the situation. Remember, we said if your R is greater than 10, you need to add another coupon here. So you're going to say 82,78936. You are going to add a coupon. Remember, our coupon, it is 14,7. Okay, there is our coupon. There is our, no, our coupon here, that is our, it is 5/2. Okay, so our D here, it is going to be equal to 5/2. You're going to add it to your, thing, to your P. So your P value is going to be that. And then when you add, you're going to get 85. Okay, this is your 85, 28936. Okay, because your R is greater than 0. Why? You see it here. The R is 33. So once you've got that, then you are happy now to go and get your all-in price, because your all-in price is this formula. This is what you're looking for. So your all-in price, because you're working with a cum interest, because your R is greater than 10, so you are going to take the formula. No, the all-in price, there's only one formula. So your formula is going to be equal to P into 1 plus Z to the power minus R over H. Okay, what is your P? You are not working with the P that you calculated, but with this P that has got, you have added your coupon. So you're going to have 8528936 into 1 plus, what is your Z? Okay, your Z is your yield rate divided by 2, which is 0,12 divided by 2. And then this is going to be your R. There is your R. It's negative 33 divided by your H. There is your H. It is 184. Okay, so your all-in price there is going to be 84,4 0.0269. So you've got all the values that you need now for your formula. Okay, you've got all of the values that you need for your formula. Which values you needed this is given. Okay, so what you do, you go and get your clean price and say, now my clean price is, what is all in price? There is my all in price after I've calculated it. It is 84,402.69 minus, what is my accrued interest? I don't need to calculate it. It's given to me. It is 2,06849. Then my answer there is going to be 8,233,420. Okay, then you've got the percentage or whatever. So this is just it's a way of re-emphasizing the process of calculating all in price and clean price. So what is important, you can see, is the R and your H and your N. And if your R is greater than 10, then you know what you're working with a cum price. That's all I have for you. Otherwise, this is it for today. Good luck for your exams. We might meet again. So thank you so much.